Okay, Physics 30s, working on question number 7. Let's wrap this up. So we're looking at a 120 watt monochromatic bulb creates light with a wavelength 5.6 times 10 to the negative 7 meters. What's the wavelength of this light in nanometers? Well, 560 e negative 9 is what 5.6 times 10 to the negative 7 is. And so that would be 560 nanometers. In part B, what's the period of the source electrical vibration in the light bulb? Well, since we have the idea of the wavelength and speed is frequency times wavelength from the universal wave equation, the frequency is 1 over the period, so the speed is 1 over the period times the wavelength. So solving this one for what we need here, which is the period, we have lambda over c. So 560 e negative 9 over 3 e8. And the calculation. 560 e negative 9 over 3 e8. 1.86 repeat e negative 15 seconds, or roughly about 1.87 e negative 15 seconds. And part C, if the bulb is 20% efficient, then determine the time required for this bulb to emit 8 times 10 to the 22nd photons. Answer in minutes. Well, the total electrical energy is transformed into, well, light energy plus probably thermal energy, obviously, right? Maybe a little sound. So 100% electrical energy comes in, 20% comes out with light energy, and 80% thermal energy. Okay? So what we want to do is we want to look at the idea of power. If the power is 120 watts coming in, then how many watts is really in terms of light energy? How many joules per second are produced? Well, 20% of 120. So 120 times 0.2, we've got 24 watts produced here. And the remainder, 96 watts of thermal energy. Okay, so that's a good starting point to kind of understand how much of the energy is light energy, which corresponds to the number of photons. Let's look at the energy of each photon. So that'll be hc over lambda. So 6.63 e negative 34 times 3e8, all divided by what we have, 560 e negative 9. So try this calculation out. 3.55179 e negative 19 joules. Okay, so then the total energy of the photons is going to be n h, or n times e photon. So I'm going to multiply the 8e22 times this answer here, 3.55. Shift it over a bit there. 1 and so on, 1 8 e negative 19. So the calculation, 28414.29 joules. All right, I think we're in a position to solve the rest of this question here. So we have the total energy of the photons, which corresponds to the light, and we want to know, of course, the time required. So if energy is power times time, then the energy of the photons goes here, and the power is the 24 watts. So this number here and this number right here. Okay? Oh, that drat light. Time is going to be energy over power. And so put it all in. 28414.29. Divide that by my 24. And let's see what we get for a number. 1183.93 seconds. And so divide your answer by 60, because there's 60 seconds in a minute, we get 19.7 minutes. All right, you can try the other questions in this section. They're actually pretty fun. If you have any troubles, please let me know. I'm here to help.